Okay, so this is number 27 on chapter 9. A billiard ball moving at 5 meters per second strikes a stationary ball of the same mass. After the collision, the first ball moves at 4.33 meters per second at an angle of 30 degrees with respect to the original line of motion. Assuming an elastic collision and ignoring friction and rotational motion, find the struck ball's velocity after the collision. Okay, so first we'll start with a diagram. So this is going to be the before, and so there's a ball of mass m, and there's a second ball of mass m, which is moving at 5 meters per second. And then after, the ball will, so this ball will be moving this way, and then the ball that struck it is going to be moving this way. And this is going to be 4.33 meters per second. And the angle is going to be 30 degrees. And for this one, we don't know anything about it. Okay, so since we're ignoring friction, the momentum is conserved. So m1, or we'll go with the same mass, but mv1 initial in the x direction. So we have to do components because it's two-dimensional motion. Plus mv2 initial in the x direction is going to equal mv1 final in the x direction, and the momentum of the second ball in the x direction. So for their diagram, if we call, we'll call this ball V2 and this ball V1. So, there is no initial momentum for ball 2 because it's stationary. And for ball 1, the initial momentum in the x direction is 0 because everything's in the y direction. So this is also 0. So, so the velocity of the second ball in the x direction is going to be the negative of the velocity of the first ball in the x direction. And we know that this is going to be negative 4.33 meters per second sine 30 degrees, because this is going to be sine 30, c sine 30, and this is x direction. So this will come out to be negative 2.165 meters per second. So then that's for the x direction, and then for the y direction, we have, and so we'll do conservation of momentum again. So that will be mv1 not y plus mv2 initial y equals mv1 final y plus mv2 final y, and this is going to be 0 because there is no velocity for ball 2 initially. And then we can cross out all the m's because they're the same mass. So the velocity to final in the y direction is going to equal v1 initial y minus v1 final y. So this is 5 meters per second minus 4.33 meters per second cosine 30, which equals 1.25 meters per second. And I just realized that we should define which way positive and negative. Okay, so we have the final velocity of the second ball. We have the x component here and the y component here. So we can find the total final velocity, the resultant vector. So for ball 2, this is going to be the final velocity, and this is going to be the x component, the y component. So the velocity of the second ball, the one that was struck, is going to be the square root of negative 2.165 meters per second squared plus 1.25 meters per second squared, because this is just the Pythagorean theorem, and that's going to equal 2.5 meters per second, and theta is going to equal the inverse tangent of 2.165 over 1.25, because, well, this is x and that's y. So because theta is going to be this angle here, because I decided to measure off the vertical, and this is going to equal 60 degrees. So, but since it goes to the left, it'll be negative 60 degrees. So your final answer is 2.5 meters per second at negative 60 degrees with respect to the original line of motion.